All right, so I'm going to return to the fact that we had some factorization that went on. I'm going to take one step back on the screen. We can see that we have a -1 is one of our solutions, a 2/3 is one of our solutions, and then we had both the positive and the negative of 2 plus or minus square root of 2. All right, in this case, I want to show, there's a trick to this, and I want to be sure that I show it. First of all, I want to make a minor correction here. Here's our third. So in this case, right, these are both x minus 2 minus the square root of 2, or x minus 2, x plus the square root of 2. So what I'm going to do in this particular instance, and I'm only talking about these guys here. This is not to ignore the rest of everything else. I want to address this piece. All right, so I'm going to use the associative property here. And instead of saying x minus 2 and the 2 minus square root of 2 and the 2 plus square root of 2 being inside the parentheses, I'm going to change that up. I'm going to use that associative property to give me x minus 2 minus the square root of 2. All right, and then I'm having same deal. I'm going to move my x minus 2. I'm going to regroup these using associative property, and then I'm going to have a plus square root of 2. All right, and so what that gets us is you're going to have this step. I'm ignoring this for the moment, but you wouldn't do that for the big picture. In this case, we're going to have an x minus 2, that whole quantity squared, and then I'm going to have minus, right, because I have a plus and a minus there, 2. Because I have a square root of 2 times the square root of 2, that's going to give me a 2. All right, and again, if I were to, at this point, I would bring everything down, x plus 1, and then I'd have x minus 2/3, and then we would expand this, I'd multiply these through, and ultimately we would come to our final answer, which would give us a degree of 4 in this case. All right, so here's the thing with, this is Descartes' rule of sign, and it looks overwhelming. It feels like there's a lot being said here, but if you get a handle on what's being said, it's actually a really useful tool. All right, so the same as the number of variations, which means a sign change, right? Let me just specify that. It's a sign change. All right, the same as the number of variations, the sign of the polynomial function p of x, or less than the number of the variations of the sign of p of x by a positive even integer. So if I have 3 variations, I could have 3, or I could have 1, because I'm going to take away 2 from that 3. All right? So it's going to be important that we keep that little fact in mind here in a moment. The number of negative real zeros, is going to be the same as the number of variations, right? Again, our sign change. When we use p, the polynomial function p of negative x, or less than the number of variations by a positive even integer. So I want to point out here, if I have a 1, there's my one real solution. I don't have any way to get rid of that, right? That's my real solution. So, and this goes back to our saying we have at least one complex. In this case, we actually wind up with one real. All right, and multiplicity, you're going to count it m times, right? Whatever the multiplicity is. All right. So we're going to organize these from least to greatest, and we are not going to put in 0 terms, right? So in this case, I'm going to have a 2x to the 5th. I'm not putting in a 0x to the 4th or a 0x to the 3rd. I'm going to just write it this way. It's either least to greatest or greatest to least. Doesn't really matter which way we go. So here to here, I have one sign change. And from here to here, no sign change, right? And from here to here, I have one sign change. So I have a 2. So that means I either have 2 real solutions or I have 0 real solutions. All right? Because remember, I have to subtract by an even number. So if I have a 2, I could have either 2 or 0. I can't have anything else. All right, so the number of variations here is 2. So you're either going to have 2 or less than 2. And in this case, the real numbers is 2 or -2, like we just said. 0, a 0 negative numbers, a 0 number of zeros is not, it's not impossible, but once you start hitting like any kind of negative numbers, right, we don't just subtract 2 randomly and just keep going. It's you stop at 0, right, 0 or 1. So in this case, we're going to go ahead, we're going to do the negative side of the same process. Now, I'm going to point out that when we do this, right, our negative, okay, I'm going to go back to this the previous page and show that we had a positive 2x to the 5th. Well, if I put in a negative x in here, right, because this is raised to the 5th power, I'm going to have a negative result. So I'm going to wind up with a negative 2x to the 5th, which is exactly what we have here. So what I've done is I put in that negative x and sorted out what the signs are going to be. All right, so in this case, I have a negative to a negative, which gives me 0. Here I have a negative to a positive, which means I have 1. And then I have a positive to a positive, which means I have 0. So here I have one real solution. And there's no other options because I can't subtract 2 from that. All right, so your results are going to be, you have a couple options here. We have, from our previous page, we have either 2 or 0. That's our positive reals. Our negative reals, we're going to have 1 or 1. Right? That doesn't change. And then our complex or irrational, one or the other, you're going to wind up with, well, what's our degree? Our degree is 5. So here you have a 2 plus a 1. That means I have to have at least 2, well, I'm going to have exactly 2 more solutions, and they're going to be either complex or irrational. Here I'm going to actually, they would just be complex. Now that I think about it, they would just be complex because irrational numbers do not, they're still part of the real numbers. And in this case, I'm going to have 1 negative real. I have 0 positive reals, which means I have 4 complex reals, or complex numbers, real complex solutions, not reals. All right. I know this was kind of quick, but if you have questions, feel free to ask. And I have some videos up regarding how to address both complex and irrational numbers as far as using them as zeros. All right?